Hey everyone, and welcome back. Today, we are diving into something absolutely fascinating for all you aquarists out there. We are looking at the ultimate engine room of a saltwater aquarium. Yep, we're talking about the sump. Now, if you are a focused learner who really wants to understand how a reef tank survives and, more importantly, thrives, you are exactly in the right place. Far too often, beginners treat the sump as just this extra glass box of water hidden away under the stand, just a place to chuck noisy equipment, right? But as we'll see today, it's so much more than that. It is a vital, holistic life support system, a highly engineered control center. Consider this mindset. A sump is way more than just a quote-unquote second tank. It's where you control filtration, manage water volume, and stabilize system behavior for a reef aquarium. So the crucial point here is that the sump is the absolute heart of your reef tank's stability. It's not an afterthought, it's literally the core foundation that dictates whether your tank is going to flourish or just struggle along. Just to make sure we're all on the exact same page, let's define what a modern sump actually is. It's the control center for maintaining steady salinity, temperature, and nutrient levels, all while making your routine care way easier and a lot safer. Think of it as the engine room of a ship. This carefully designed space is what takes a chaotic, constantly fluctuating reef environment and turns it into a manageable, predictable, and thriving ecosystem. To really wrap our heads around how this engine room works, we are going to take a quick anatomical tour today, following the logical flow of a single drop of water through the system. We'll start with the heart of the reef, move on to sizing your sump, check out the mechanical and skimmer stages, dive into nutrient control and refugiums, look at the return and auto top-off, and then wrap the whole thing up with best practices for stability. Let's get right into it. Section 1. The heart of the reef. Setting the foundation. Every successful reef tank relies on a robust set of core principles, and the sump is really where those principles are put to the test. Look, while every single aquarist setup is uniquely tailored to their own home and their specific livestock, the absolute most successful reef tanks out there share the exact same foundational sump elements. Experienced reef keepers treat these elements as totally non-negotiable. It really highlights why it matters to treat the sump as an engineered control center right from day one, rather than just a messy dumping ground for your extra gear. Section 2. Sizing your sump, building the footprint. Let's talk physical constraints and volume requirements, because getting this size right, that's your very first hurdle. Now, what's really interesting about this slide is how it breaks down the exact logic of sizing your sump. Step 1 is pretty obvious, right? It has to physically fit inside your aquarium stand. But steps 2 and 3 are where the real engineering comes in. You absolutely must allow extra water volume for safe evaporation. And, crucially, you need enough free volume so that when your return pump stops, like during a sudden power outage, all that water draining down from the display tank rises safely in the sump without spilling all over your living room floor. A larger sump is honestly always better because it actively dilutes any swings in your water parameters, creating a much more stable environment. Section 3, Mechanical and Skimmer Stages, the first line of defense. Let's see how our water path actually builds into those first chambers. When water drains down from your main display tank, it's carrying detritus and debris. You need a chamber that catches this waste right away, before it can recirculate. Now, you've got a few mechanical filtration options here, like filter socks, sponges, roller media, or structured filter pads. The main goal here is rapid particle removal to stop dissolved waste from turning into a massive nutrient spike. And hey, if you go with filter socks, you have got to treat them as active consumables. They require frequent, scheduled changes. This means your sump design must let you access and swap them out easily without having to tear the whole plumbing system apart. Right after mechanical filtration, that water typically flows to your protein skimmer. The skimmer is the absolute workhorse for exporting organic compounds in a reef system. But here is the critical takeaway. Skimmer placement matters immensely. A skimmer needs a perfectly stable water depth to run consistently. If you stick it in a chamber where the water level fluctuates, its performance is going to swing wildly, completely ruining its long-term reliability. A properly designed sump uses baffles to create a dedicated, constant level chamber just for this one piece of equipment. Section 4. Nutrient control and refugiums, fine-tuning water quality. Our water's journey continues as we move right into the chemical and biological filtration stage. Welcome to the reactor chamber. This is a space totally dedicated to fine-tuning your water quality. A lot of reef keepers use this area to run a refugium full of macroalgae or to house media like activated carbon and, when appropriate, GFO for phosphate control. What's absolutely essential about this chamber is that it has to be separated from your main return section. You really want a distinct zone where you can dial in flow conditions and do your routine media maintenance without disturbing the delicate balance of the rest of the sump. For those of you choosing to run a biological refugium, success isn't accidental, and this brilliantly illustrates the point. A successful refugium requires consistent lighting, proper flow, and absolutely zero detritus buildup. If detritus settles in there, it completely undermines the very nutrient export goals the refugium is supposed to achieve in the first place. Proper sump design ensures swift flow through this chamber, keeping things perfectly clean while the macroalgae does its job. Section 5. The return, and ATO, the final stage. Now we guide our water into the final chamber, where it gets prepped and sent right back up to the display tank. But before that water heads back up, we have to ask a really important question. What happens when water evaporates from the system? I mean, it's a completely natural process, right? But here's the catch. In a saltwater tank, only the fresh water evaporates. The salt is left behind. This means if you don't replace that exact amount of evaporated water, your tank salinity will slowly but surely drift upward, and that creates a highly stressful environment for your corals and fish. No one wants that. To combat this salinity drift, modern sumps use an ATO, or auto top-off. It's a super reliable sensor setup placed precisely in the return chamber. Why there? Because that is the only chamber in a properly baffled sump where the water level actually drops due to evaporation. The ATO automatically replaces that evaporated water with fresh water. It's basically your ultimate safety mechanism. Not only does it maintain steady salinity, but it also prevents accidental overflows during maintenance by keeping the total system volume perfectly constant. Section 6, Best Practices for Stability. Tying it all together. We followed the water all the way from the drain down to the return pump. Now, let's zoom out to the overarching rules. Okay, let's dive into this list of essential design habits, because honestly, even with the best equipment in the world, small design decisions will absolutely make or break your day-to-day operation. First, use baffles intentionally to quiet the water flow and keep your skimmer depth totally stable. Second, always plan for power outages by calculating that drain back volume we talked about earlier. Third, manage your sequential flow paths. Water has to pass through mechanical filtration and skimming before it ever hits the return. And finally, keep maintenance accessible. Seriously, you should never have to dismantle your plumbing just to change a filter sock or clean a pump. This brings us to a major perspective shift. Look at the difference here between a quote-unquote working sump, where someone buys equipment first and frustratingly shoves it wherever it happens to fit, versus a truly reliable sump. That reliable one is achieved by planning your layout and water flow logic first, and then deliberately selecting equipment that matches that specific design. I really want to anchor this golden rule in your mind right now. Layout and water flow logic come first. A brilliant sump design isn't about what brand of fancy gear you buy. It's about how the chambers structurally work together. When each stage is sized and positioned with stability and serviceability in mind, maintaining your reef tank becomes predictable and, honestly, a joy rather than a chore. Which leaves us with this final thought to take away from today's explainer. Take a hard look at your own filtration plans and ask yourself, are you just buying aquarium gear, or are you engineering a predictable, stable engine room for your reef? Thank you so much for joining me today. I really hope this structured look at sump design empowers you to build a better, more stable environment for your aquatic life. Keep learning, and I'll see you on the next one.